Hello everyone. This is the second of two tutorials created using Blender version 4.2, where we'll explore some basic methods for cutting and separating parts of mesh objects in Blender. In this session, we'll look at how to use the Boolean modifier, which allows us to work non-destructively on objects and to implement changes flexibly. We'll also see how it's possible to view or render a section without modifying the object in any way, simply by setting the start clip or the end clip of the 3D viewport or the virtual camera. Before moving on to the Boolean modifier, let's briefly review what we covered in the first part and discuss the differences between operators and modifiers in Blender. The bisect, split, and separate tools are indeed operators, meaning they work destructively, unlike Boolean. Boolean, on the other hand, is a modifier which allows us to revert to the previous mesh, even temporarily undoing operations or adjusting the shape of the cut at a later stage. The three operators examined in the previous session are therefore very fast, but are suited for simple cuts or separations when we're absolutely sure about the cuts we want to make. On the other hand, if we're unsure about the operations to perform or if the cut is not straightforward, the Boolean operator is the one to use. Another point to consider is that if you decide to use split or separate, it becomes important to know more about selection tools for parts of an object, such as the more and less operators or UV island selection. I'll cover these and other techniques in another video tutorial. Okay, that being said, let's talk about Boolean. Boolean is a modifier that performs an operation between two objects. The first object is the one with a modifier, while the second object is defined as the target object. This order is important because Boolean operations involve intersections, subtractions, and unions between geometries. For union, there's no noticeable difference if the modifier is applied to one object or the other, but with the difference in the intersect modes, the results change. Saying that a geometry should result from geometry A minus geometry B is different from saying it should be B minus A. One of the advantages of using the Boolean modifier, besides the obvious benefit of being a non-destructive tool, is that the geometries can be moved, rotated, and generally modified while the modifier is applied, which means you can even insert keyframes to create animations. In the case of the cake animation I showed at the beginning of the video, which we'll examine in more detail shortly, the Boolean modifier was applied to the cake. This means there's another invisible object that grows during the animation until it completely hides the cake. Next week, I'll publish a tutorial where I'll show you how to animate the profile being subtracted from the cake, so subscribe to the channel and enable notifications if you haven't already. The Boolean modifier on the cake object is set to difference mode, and the invisible growing object is assigned in the object field of the modifier, so the resulting geometry is the geometry of the cake minus the geometry of the invisible object. The modifier may seem very straightforward to use, but not everything that glitters is gold. Issues with the Boolean modifier have been well known in the Blender community for a long time, and in recent versions, developers have been improving the algorithm and introducing new tools for better results. Specifically, to achieve the result you saw in the video, I had to set the solver mode to exact and then enable the self-intersection option in the solver options section. These settings make the calculation of the Boolean operation slower to the point where I can't show you a smooth animation in the 3D viewport preview, only a few frames occasionally. With other solver settings, I encountered various errors. These settings provided a good result at the cost of increased processing time. The results also greatly depend on the topology of the objects used. Generally, it helps if the objects have volume. In this particular case, the original model had the top and bottom surfaces of the cake closed in triangle fan mode, meaning they converged at a single central point. It was helpful to remove that central vertex and close them with the grid fill operator. I also had to apply a smooth by-angle modifier to the cake object to solve some shading issues caused by using the Boolean modifier. Before closing this tutorial, I'll show you how to display only a portion of the 3D model by adjusting the clipping distances of the camera in the 3D view. This is a way to visualize parts of an object without modifying it in any way. But first, let's understand what these distances are. The 3D view in virtual cameras do not render all objects within their field of view, but only those located within a space defined by two values, known as clip start and clip end. For the 3D view, these values are found in the View tab of the sidebar in any 3D viewport editor. You may have encountered the clip start and clip end of the 3D view if, for example, while zooming in on an object, the parts closest to you suddenly disappeared. In this case, the clip start value was greater than the distance of those parts of the object from the 3D window viewpoint. To fix this, simply lower the clip start value. You might have also encountered an issue with an incorrect clip-in value if, for example, the object was not visible even after repositioning the 3D view to frame the object using the period key on the numpad. In this case, the clip-in value was likely too low and the object was at a greater distance. There is therefore a way to view only the outline of the object, as if we were cutting it at a certain distance from the observer's viewpoint. Simply set a clip start value equal to the distance where you want to make the cut and a clip in value slightly greater than clip start. The clip start value only takes effect if the view is in perspective mode, while in an orthographic view, you'll only need to adjust the clip in value. However, adjusting the clip start and clip in values in perspective mode is not very convenient because, of course, the result will change as soon as you move the viewpoint within the 3D scene. For virtual cameras, these values are found in the Lens section of the Object Data tab. The values are called clip start and clip end, as in the 3D viewport, but in this case, the clip start value also takes effect if the camera is in orthographic mode. You can see the clip start and clip end points if you enable the limits options in the viewport display section of the Object tab of the selected camera. This is very useful to be able to set those values precisely. Well, that's it for this video tutorial. I hope you found it helpful. See you soon.